I think, Melody, we need to kind of move on and show the interstitial video now, but thank you so much for an amazing keynote. Should we do that?
Yeah, I think that would be great.
Awesome. We're going to talk Azure Functions. Let's get the quick review of what that means.
Up until now, the problem with building applications has been that before you could even start, you had to choose a framework, learn how to deploy that framework onto servers, then manage and maintain those servers over time. Not exactly easy, quick, or efficient. Thankfully now there's Azure Functions, the easy way to build the applications you need using simple serverless functions that scale automatically to meet demand. No worrying about infrastructure or provisioning servers. Whether you're new to development or a seasoned pro, within a few minutes, Azure Functions helps you create applications that accept HTTP requests for a website, processes product orders via queue messages, react to data flowing from devices like an IoT hub, or just run simple scheduled tasks. And since Azure Functions scales automatically, all you need to do is write your function logic. Azure Functions handles the rest. What's more, you only pay for what you use. With Azure Functions, you'll write less code, manage less infrastructure, and have a lot less upfront costs. See for yourself at functions.azure.com and try it, free. You'll see that making applications has never been easier with Azure Functions.
Well, that was really good.
Automate all the things.
Yeah, I know. Between that keynote of automation and then now with the Azure Functions, I really think we're ready to move on to the next segment of media processing workflow with Azure Serverless with Braden and Jayson. Are you guys ready?
Yeah, absolutely.
Yep.
All right. Well, we'll get started. Hi, my name is Braden Riggs. I'm part of the developer relations team here at Dolby.io.
Hi, and Nancy, I lead that team.
Yeah, Jayson is being really modest. He's been a mentor and has really helped me through this project from the beginning, and he's kind of here to help answer questions while I present. So before we get started, if anybody does have some questions, please post them in the chat as we go along with what your use case is, and when we get to the end, or maybe a little bit during the presentation, we can chat about them. So before we dive into serverless media workflows, let's quickly speak about what Dolby.io is. So Dolby.io is a self-service platform that provides a number of APIs that allow developers to build communications, media, and streaming solutions for things like podcasting and telehealth. The APIs come in two flavors: are communications APIs, which focus on real-time streaming and communication technology. So think like building your own live streaming platform. And our media processing technology, which offers solutions such as music mastering, audio analysis, or audio corrections and enhancement. Dolby.io is really just taking the signal processing technology that Dolby itself has been using in cinemas and music studios and packing it up in a way that allows developers to deliver it in their products. So why are we Dolby.io here, and why are we talking about serverless technology? As I mentioned, the Dolby.io team have been developing a series of media processing APIs, some of which can be used for data generation tasks, for things like speaker diarization, number of talkers, quality scoring by talker, and things like that. I've been working on this project where I take these large collections of sports podcast recordings, and I use these generation tools to create sets of data, which can generate insight into the macro trends relating to podcast creation. So we take these podcasts, analyze them with our media tools, and aggregate the results into data sets that we can use to explore these trends in podcast production. Now, this project started locally, but as I'm sure you can guess, the storage and processing requirements quickly ballooned to a size that was just no longer appropriate for local development. Additionally, our APIs generate insight specifically from the signals in the audio, and hence we don't create transcriptions of the spoken words. For this project, I was interested in also exploring the relationships between spoken words and sports podcasts, and hence I wanted to create transcriptions of the audio data. And as this project grew in scope, I began looking at cloud environments where I could scale up this project to align with my goals. And this is what got me started with Azure Serverless and developing media processing workflows. So to get a little bit more specific, what were my goals for this workflow and what did I need to do? Well, first, the workflow needed to have a filter of some sort to distinguish quality audio from poor audio. And this is because in sports podcasts, especially in the sports podcasting space, these things can vary wildly in quality, especially when shows have several guest speakers, each calling in from a phone or using microphones of varying quality. It doesn't make a ton of sense to transcribe low quality audio, as the results will likely be inconsistent and noisy. So the first requirement for my media workflow was to create a filter that can ensure we were putting transcription to good use. Media designated to be quality would be transcribed and added to our data set. Secondly, we want to keep the low quality audio and clean it up using some noise reduction tools. This is so we can take the designated low quality audio and manually explore some options to trim out the bad sections or review it for quality checks. Third and finally, I want this whole process to take place on the cloud in a ditch effort to save my poor computer from having to store all of this media and process the output transcriptions. Now, of course, I'm here today because we were able to accomplish this whole process, leveraging the power of Azure Serverless technology. In fact, as we're going to show, we didn't need to set up like a virtual machine. We were able to create this tool that can do either one job a month or scale to handle thousands of jobs a day without us really having to change anything at all, and at a really reasonable price. So before I talk about what the serverless process looks like, let's discuss a few of the individual tools that we use to help accomplish these tasks we outlined. So to solve the first challenge, we can leverage a Dolby I/O API called Diagnose. Our Diagnose API is a tool that can perform lightweight analysis on media for a quick evaluation of the quality of the audio, along with other metrics and metadata. This allows us to route media through the Dolby I/O servers to return a quality score for the audio, which we can then use to filter the media into a transcription group and like a correction group. So what does implementing a tool like this look like? Well, in Python, using the Dolby I/O Diagnose REST API, it's pretty easy. We start by formatting a header with our Dolby I/O Media API key, which you get when you make an account. And we also include the URL that directs the request to the appropriate Dolby I/O server, in this case, our Diagnose server. Next, we format a body. And for this stage, we provide a URL that points to the location of our media that we want to diagnose. So in this case, that URL is our pre-signed URL for our Azure media storage. Finally, we post this request. If everything's formatted correctly, you receive a job ID. And after waiting a few seconds to a few minutes, depending on the size of the media, we can use this job ID to get returned results relating to specific audio problems, such as speech sibilance and silent channels, as well as a quality score, which is pictured on screen, that we can use in our workflow to decide whether we want to proceed with a transcription. Now, the audio score is on a scale of 1 to 10, where 1 is poor audio recorded on a low quality mic, and 10 is excellent audio quality, likely professionally produced. So in this example, 6 is pretty average, not good, but average. However, if we're spending the computational power to transcribe audio, we want to be accurate, and hence we don't want to transcribe anything with a quality less than 7. So it's worth noting that there's nothing special about this threshold of 7. It's just that in our testing, that seemed to work best for transcribing sports podcasts. If the audio quality scores below our set threshold, we instead need a tool to clean up the audio so we can experiment with alternatives to transcription. The Dolby I/O Enhance API is excellent for this task, as it automatically reduces noise, levels speech, and corrects loudness, among other things. So much like the Diagnose API, the Enhance API is formatted in a similar way. In this case, we create a body, and the body includes an input and an out location. This is because Enhance outputs an enhanced file, as opposed to Diagnose, which just returns some data relating to media. So in this case, both the input and the output URLs are pre-signed Azure Blob Storage URLs. We also include a URL that points to the Dolby I/O Media Enhancement API. We format this header in the same way as we did for Diagnose, and we post. In this case, we don't need to track a job ID because when it is done, we'll instead have an updated file on our container. So what exactly is this Enhance API doing? Well, here I have an example spectrogram of one of FDR's early speeches recorded in 1941. A spectrogram is a way of visualizing audio as a series of signal strengths over time. Now, if we take note of this particular segment here, and let me zoom in on it so it's a bit easier to see, we can see that in the enhanced audio, the spikes of signal are more distinct from the background. These spikes of signal are actually spoken words. So what the Enhance API has done is separated the signal from the noise. And this is useful for further experimentation where we can look to clean up the audio and maybe trim out some of the bad parts or even explore alternatives to transcription altogether. Our third tool that we use is the Azure Cognitive Services Speech-to-Text REST API. Once we've filtered our audio and are interested in getting a transcription, we can use this API to generate our text data. Speech-to-text works by formatting a header with our speech-to-text API key and by specifying the region-dependent server where we want to post this request to with the URL. We also format a body, and in this body, we specify some parameters such as the location of our file and the container we wish to output the file into. Then finally, we post this request and let the text-to-speech magic happen. So once the transcription is done, the results are output into a JSON file in the specified container. And in this case, we get a few different models for transcription, and we can pick one that works for our results. Okay, so those are our tools. Now, how do we put them all together in a function? So pictured on screen is a diagram of how all these pieces fit into a serverless function. We have our Diagnose tool, which we use to distinguish quality audio from poor audio. We have our Enhance tool, which we use to clean up the poor audio for further research. And we have our Transcribe tool, which we use to generate a transcription of the media that has a Diagnose score above that threshold of 7. Now, using these tools in isolation is one thing. However, part of this project is to create an environment that can scale to handle hundreds of jobs all asynchronously. Let's talk a bit about the few tools that we use to accomplish this serverless part. And then we can come back and have another look at the diagram. So for this project, we decided we want to wrap it all up in an Azure Serverless function. One part because we're already using Azure Speech-to-Text tool, and another part because the process to hello world, or rather getting started, was so quick and intuitive that I could just focus more on the complex parts of the project without stressing about building environments, etc. Specifically, we initialized this project in a Python environment and built the project using VS Code. Very quickly, I was able to create the environment I needed to instead accomplish this media workflow. So some of the tools that became especially handy were using triggers to handle the workflow. Now, there's two main triggers of specific interest in our use case. We have our HTTP trigger, which which would be perfect if we developed our project to work as a web app. And we have a blob trigger that could be used to function as like a cloud-based hot folder where every time I automatically place a file on there, it starts this whole media workflow automatically. So we then manage the job flow asynchronously using callbacks, which could trigger the HTTP trigger to move on to the next stage of the workflow, whether that be transcribing the audio or enhancing the audio. Great. So now we have all the tools we need to build the workflow. We use triggers and callbacks to help direct the workflow. And we use tools such as Diagnose and Speech-to-Text to accomplish the goals of the workflow. Using serverless, we can wrap all these tools together into a single function, which can be triggered on a hot folder or on an HTTP trigger. This workflow could then be integrated into a web app if we want to make it a public tool. So you can see on screen we have our app in the bottom left corner. This app either triggers an HTTP request or uploads a file to an Azure hot folder. This event then triggers the serverless function, which begins the workflow by diagnosing the audio. As the diagnose completes, it triggers a callback, which brings us back around to the media workflow function. Using the Diagnose Audio Quality Score with the workflow function, it can either decide to enhance the low quality audio, which again triggers a callback on completion and signals that the job is done, or it will trigger the audio with the speech to text tool, which will then provide a notification of job completion upon transcription. All of this together constitutes the workflow, which can run asynchronously depending on how many files we want to pass through the workflow. So to recap, what does the serverless function accomplish? Well, for one, it provides a viable filter to help ensure we're getting the most bang for buck for our transcriptions. Two, it provides a path for our low quality audio to be cleaned. And we can review this low quality audio later with our audio engineers to see if there's a solution. And three, the whole media workflow is entirely serverless and asynchronous, meaning that we can run several jobs at once without having to worry about anything overlapping or interfering. So I'd say mission accomplished. But what did we learn from this project? Well, the first thing we learned is that media data is sneaky big data, in that the scale and size quickly sneaks up on you, and you have to be prepared to develop in an environment that can scale with the data. Two, we learned that callbacks and webhooks are critical to asynchronous processing, especially when you're working with REST APIs. By using webhooks, we don't have to leave our functions tied up in jobs when that stage of the job is being handled elsewhere. This also allows us to run multiple jobs asynchronously, letting the Azure Serverless adjust resources accordingly. Third, triggers are your friend. I especially want to emphasize this point because picking the right trigger is critical to creating a tool that you want to use and that works for your circumstances. Great. So with all that said, I want to take this tool and share it with the serverless community so you can experiment and play with it. And we have a link to our GitHub here, which hopefully we can drop in chat. And we're also looking to add our project to the Azure Community Serverless Library. But if you follow me on Twitter or reach out via email, I'm happy to let you know when the tool has been approved so you can play with it yourself. And with that said, thank you to everybody who listened to my presentation. If you have any questions, I think me and Jayson still have a few minutes left on the clock. Otherwise, please feel free to reach out to us on Twitter. Yeah.
Absolutely. That's fabulous. That was a great session. I particularly liked how you were able to put a couple of those functions together and string them together. So when you did that, what did you find were some of the best benefits of that? And if you were to add something additional to that to improve it in the future, what do you think that would be?
Mm-hmm. Yeah, well, for the most part, our process is really bare bones right now. Like we're just taking this file, we're filtering it into a transcription group and then into a repair group. And I think the biggest benefit of doing that on serverless, right, is this idea of scaling up. And especially with a project like this, where, I mean, we are handling like anywhere from maybe just a couple of podcasts to thousands of podcasts. It's just so nice to not really have to worry about hardware limitations or building these environments. Instead, we can just run it and have it scale accordingly on Azure's side. Now, if we want to build this out even more, I definitely would love to take the workflow and make it a little bit more advanced, implement things like transcoding tools so that we can handle multiple file formats, and also include some sort of apparatus that can then take our transcribed files and maybe put it onto a SQL database so that we can help have a really nice aggregated set of all of our data from the stuff that we're generating with our own APIs in terms of number of talkers to all the transcription stuff that we're able to get from using the Cognitive Services API.
That makes sense. One of the questions from our audience is, Mark asks, what kind of input-output locations are available? Yeah.
So in terms of input-output locations, for this project, we specifically focused on using Azure Blob Storage. However, Dolby.io does also handle something on their end where you can integrated with our API, you can upload the file locally, and it can kind of handle the input and the output of the file and then return it to locally. I don't know if Jayson wants to add anything on that.
Yeah, I mean, our media processing engine's pretty flexible in that regard, and usually by being close to processing the data, you avoid any egress, transferring of. So working directly with blob storage made a lot of sense in this project.
Okay. Pimonto wants to know when will Logic's apps variables support getting variables from Key Vault like Azure Functions with a Key Vault URI?
To be honest, off the top of my head, I'm not sure if I fully understand the question. We got variables supported getting variables from our.
Yeah, I was going to say that's probably a question for the Azure Functions team, because they're asking, or the Logic Apps team. So we could put that in the chat and see. It may not be specific to your use case unless you knew.
Okay.
Makes sense.
But I like the next question. Franco's asking, how do we apply your solution to, let's say, the Olympic Games? This I want to know, because I think one of the amazing things I liked about the workflow is the ability to do localization or kind of just adapt that transcript and kind of have that be simultaneously with triggers, right? Like you can simultaneously get this in different Olympic Games, United Nations, both same thing. How would you do this? What are your ideas?
I mean, it's no coincidence that I was looking at sports podcasts this past year, and the Olympic Games were on. So assuming that you had either the recordings of the Olympic Games now that they're done, or some way of collecting them live, our tool that we've posted pretty much just can handle it as like a hot folder. So you drop it onto the Azure, into a particular Azure container, which you can set up yourself, and it can then just automatically take it through the whole workflow. You can set a threshold for, either generating a transcription or not generating a transcription. And it works. It works pretty seamlessly. You can even have a continuous stream in there if you mess around with it a little bit.
Yeah, and I think that's one of the reasons contributing it to the community library lets people have access to it for customization, right? Because it's really about orchestrating a bunch of these functions to perform some sort of outcome. And with the pace of content being created, there's a high demand, whether it's Olympics or anything, right? And also being able to turn the content around very quickly. There's lots of use cases for this type of workflow.
I don't know if there are any other questions, but I'll ask one if time permits, which is, can you do real time? So the use case that immediately came to mind is being able to recognize, bad words, things like that, and kind of bleep them out in the 5-second interval or whatever. But I see this as a great way to support community things so that you're removing harassment, you're removing that kind of stuff out of these streams. So is it possible to use these APIs in real time to do something like that?
If Jayson wants to take that question.
Yeah, sure. So the demonstration here, these are file-based media processing approach. So it's not providing the real-time filter, but some of our communications APIs and things are more geared toward real-time use cases.
Mm-hmm. Yeah, so this specific example here is like media post-processing in terms of like you already have the media, then you can send it through. Would love to have the opportunity to expand the functionality to something maybe a little bit more real time, because I agree. I think that's a really interesting use case.
And that's one of the great things about making this community available too. So that's something that as a community, it can be expanded that way too.
So I think apparently I don't know if you can hang out and go to the chat and answer more questions. There are a few questions about throttling, tips and tricks to avoid problems with throttling, or have you encountered bottlenecks with throttling? A lot of interest in that. If you want to kind of give a quick response, but we'd love to have you hop on a chat and answer that too, if that's possible.
Yeah, absolutely. If you don't mind dropping a link to where the live chat is, I'd love to take a look, because a lot of these questions, I really would like the opportunity as well to follow up and maybe give a more detailed response, so I'm not using up everybody's time here.